Everything you thought you knew about the beginning of time is wrong. For decades, we had a perfect story, a neat mathematical timeline that explained how a hot, chaotic soup of particles cooled down to become the majestic universe we see today. We called it the Big Bang, and we were certain we had the details ironed out. But then, we sent a massive golden eye into the deep silence of space, orbiting 1,000,000 miles away from Earth, and it saw things that simply should not exist. The James Webb Space Telescope didn't just find a few old stars. It found massive, ancient, and impossibly mature galaxies sitting right at the dawn of time, defying every law of physics we've ever written. It's like walking into a nursery and finding a group of 80-year-old men sitting in the cribs. This isn't just a small mistake in our calculations. This is a full-blown cosmological catastrophe that is forcing every scientist on the planet to ask if our reality is even what we think it is. If this mystery fascinates you as much as it does us, hit that subscribe button to join our journey through the stars. Now, let's begin our descent into the greatest mystery of our century. The story starts with light. Not the bright, visible light we see with our eyes, but ancient, tired light that has been traveling through the expanding void for over 13 billion years. By the time this light reaches us, it has been stretched so much by the expansion of space that it has shifted into the infrared spectrum. This is why the James Webb Space Telescope is so revolutionary. It is a time machine designed specifically to peer through the thick dust of the early universe and capture those first, faint glimmers of the cosmic morning. We expected to see tiny, chaotic clumps of gas and the very first, primitive stars struggling to form the first proto-galaxies. Instead, the images coming back from the deep field look like a polished, finished universe. We are seeing giant, spiral galaxies with billions of stars, fully formed and glowing with intense energy, existing just 300 million years after the moment of creation. To put that in perspective, our current models say it should take at least 1 billion years for gravity to pull that much matter together. It's as if the universe skipped its childhood and went straight to adulthood, and nobody can explain how. The problem lies in the very foundation of our understanding of gravity and dark matter. For a long time, we believed that dark matter acted as a sort of invisible scaffolding. It provided the extra gravitational pull needed to gather hydrogen and helium gas into the first structures. But even with the help of dark matter, the math doesn't add up. There simply wasn't enough time for these universe breakers, as some astronomers are calling them, to grow so large. This discovery has ignited a fierce debate in the scientific community. Some researchers are desperately looking for errors in the data, hoping that these galaxies are actually closer to us than they appear, or that they are being magnified by gravitational lenses. But as more and more data pours in, the evidence is becoming undeniable. The early universe was far more crowded, far more active, and far more complex than anyone dared to imagine. We are looking at a reality that refuses to obey our rules, and the implications are truly terrifying. If the galaxies are there, then our clock is wrong. One radical theory that has gained new life because of Webb is the idea that the universe is much, much older than 13.8 billion years. Some physicists are suggesting that we might need to double the age of the cosmos to 26 billion years, just to give these galaxies enough time to form. But changing the age of the universe isn't like changing the batteries in a remote. It breaks everything else. It changes how we calculate the expansion of space. It changes our understanding of the cosmic microwave background radiation, and it calls into question the very nature of the Big Bang itself. If the universe is twice as old as we thought, then every textbook in every school on Earth is fundamentally flawed. We are standing on the edge of a scientific revolution that could be as significant as the shift from a flat Earth to a round one, or from an Earth-centered solar system to one that revolves around the sun. But the impossible galaxies are only one half of the nightmare. There's another ghost haunting the halls of physics, and it's called the Hubble tension. For years, 2 different ways of measuring how fast the universe is expanding have given 2 different results. One method looks at the glowing embers of the Big Bang, while the other looks at pulsating stars in nearby galaxies. The gap between these 2 numbers was small, and for a long time, we hoped it was just a human error. We thought that once we had the precision of the James Webb Space Telescope, the 2 numbers would finally align and the tension would disappear. But instead, Webb has confirmed the discrepancy with terrifying precision. The gap is real. The universe is expanding at two different speeds depending on where you look and how you measure it. This suggests that there is a fundamental glitch in the fabric of space-time, or perhaps a hidden force, a new physics, that we have yet to discover. This brings us to the most unsettling possibility of all. When the math of a system stops making sense, and when the observations contradict the very laws of the simulation we call physics, some thinkers begin to look at the code. If the universe appears to have impossible objects and inconsistent expansion rates, could it be that we are seeing the limitations of a simulated reality? While it sounds like science fiction, the idea that our universe is a high-level computation is a serious topic of discussion among some of the world's most brilliant minds. If the user of this simulation changed the parameters of the early universe, or if we are hitting a rendering limit at the furthest edges of space, it would explain why our traditional physics are breaking down. Whether it's a simulation, a much older universe, or a misunderstanding of gravity itself, one thing is certain. The James Webb Space Telescope has pulled back the curtain, and the reality behind it is far more mysterious than we ever suspected. Imagine the sheer scale of this discovery. When we talk about the early universe, we are talking about a time when the first stars were supposed to be just igniting, clearing the cosmic fog of neutral hydrogen. This period is known as the epoch of Rayonization. For decades, our computer simulations told a very specific story. Small, messy clumps of dark matter would slowly draw in gas, forming tiny, irregular dwarf galaxies. These would eventually collide and merge over billions of years to create the grand spirals like our own Milky Way. But the James Webb Space Telescope has looked into that fog and found little red dots, objects that are so dense and so massive that they shouldn't have had time to grow. Some of these galaxies contain as many stars as our modern-day Milky Way, but they are packed into a space 30 times smaller. It is a level of cosmic efficiency that our current theories of gravity simply cannot explain. We are seeing a universe that was born ready, appearing fully matured and complex at a time when it should have been a dark, empty void. This forces us to re-examine the very nature of dark matter itself. We've spent billions of dollars and decades of research trying to detect a dark matter particle, but we've come up empty-handed. If these early massive galaxies exist, it might mean that dark matter isn't what we thought it was, or perhaps it doesn't exist at all. Some scientists are now looking back at modified Newtonian dynamics, or MUN. This theory suggests that gravity behaves differently on a galactic scale than it does in our solar system. If gravity is actually stronger at low accelerations, it would explain why these galaxies form so quickly without the need for invisible dark matter. But if we throw out dark matter, we have to rewrite the history of the entire cosmos. We are at a crossroads where we must either invent a new type of invisible matter that acts faster than anything we've ever seen, or we must admit that our understanding of gravity, the very force that holds us to the Earth, is fundamentally broken. The implications of this broken physics go even deeper than just the size of galaxies. It reaches into the very heart of the Big Bang itself. If the universe is not expanding at a single, consistent rate, then the cosmic yardstick we use to measure everything is useless. This is the crisis of the Hubble tension. One team of scientists uses the cosmic microwave background, the afterglow of the Big Bang, to calculate an expansion rate of about 67 kilometers per second per megaparsec. Another team uses standard candles like Cepheid variables and supernovae to measure a rate of 73. Before Webb, skeptics argued that the 73 number was wrong because our older telescopes weren't precise enough to separate the light of individual stars in distant galaxies. They thought the stars were crowded together, leading to a false measurement. But Webb has looked at those same stars with its incredible resolution and confirmed the higher number is correct. The tension isn't a mistake, it's a feature of our universe. This means that either our model of the early universe is wrong, or something strange is happening in the late universe as it ages. Some theorists are proposing the existence of early dark energy, a mysterious force that gave the universe an extra kick of expansion in its first few 100,000 years. Others suggest that there might be new kinds of subatomic particles, like sterile neutrinos, that we haven't discovered yet. But every time we add a new fix to the model, the math gets more complicated and less elegant. It feels like we are adding epicycles to a broken system, much like ancient astronomers did when they tried to explain why planets seem to move backward in the sky before they realize the Earth revolves around the sun. We are waiting for our Copernican moment, a single revelation that will make all these contradictions disappear. But for now, we are stuck in a chaotic transition where the old rules no longer apply and the new ones haven't been written yet. And then there's the question of time itself. If Webb is seeing galaxies that are too old for the universe, we have to ask, what if the Big Bang wasn't the beginning? Some models, like the Big Bounce, suggest that our universe is just one in a never-ending cycle of expansion and contraction. In this scenario, the impossible galaxies could be remnants or seeds from a previous universe that survived the crunch and blossomed in the new one. This would explain their maturity and their size, but it would also mean that time has no beginning and no end. It turns our linear history into a circle, a concept that is as beautiful as it is terrifying. We are looking at a reality where the beginning of time might just be a local event in an infinite, eternal ocean of cosmic cycles. Every new pixel of data from Webb is a hammer blow to our arrogance, reminding us that we are just beginning to learn the true language of the stars. As we dive deeper into this cosmic mystery, we have to look at the dark flow and the great attractor. If our standard model is failing to explain the early growth of galaxies, perhaps it is also failing to explain the large-scale motion of everything in our local neighborhood. Astronomers have noticed that hundreds of galaxy clusters are all streaming toward a specific, invisible point in space at millions of miles per hour. This isn't the expansion of the universe, it's something else. A massive gravitational pull from something beyond our observable horizon. When we combine this with the James Webb data, a chilling picture begins to emerge. We might be living in a pocket of the universe that is fundamentally different from the rest. This is called the cosmic void hypothesis. If we are sitting in a region of space that is less dense than average, it would distort our measurements of the Hubble constant, making it look like the universe is expanding faster than it actually is. It would mean our local physics are a lie, and the real truth is hidden millions of light years away in the darkness. But even the void hypothesis struggles to explain the sheer perfection of the galaxies Webb has found. These aren't just clumps of stars, they are structured, beautiful, and chemically complex. In our old models, the first stars, known as population 3 stars, were made entirely of hydrogen and helium. They were massive, short-lived giants that had to die and explode as supernovae to create heavier elements like carbon, oxygen, and iron. Only after several generations of these star deaths could metals exist in the universe. Yet Webb has detected the signatures of these heavy elements in galaxies that existed when the universe was just a fraction of its current age. How did the universe find the time to live, die, and be reborn so many times in such a short window? It's as if the cosmic oven was preheated. Some scientists are now whispering about primordial black holes. Massive black holes that formed not from dying stars, but from the raw energy of the Big Bang itself. If these black holes were there from the very first second, they could have acted as gravitational magnets, pulling gas together with incredible speed and jump-starting the birth of galaxies. This leads us to an even more mind-bending possibility. If the early universe was dominated by these primordial monsters, it changes the entire story of how life could emerge. A universe that matures faster is a universe that creates the building blocks of life, carbon, nitrogen, and oxygen, much sooner than we thought. We used to think that the first 5 or 10 billion years of the universe were a barren, radioactive wasteland where life was impossible. But if Webb is showing us a mature, chemically rich universe at just 500 million years, then the window for life has been pushed back significantly. We could be living in a cosmos that has been capable of hosting biological life for over 13 billion years. If that's true, the Fermi paradox, the question of why we haven't found aliens yet, becomes even more haunting. Where is everyone? If the universe broke its own speed records to create a home for stars and planets, why does the silence of space feel so empty? The crisis in cosmology isn't just about math, it's about our place in the grand design. We are seeing a universe that is more energetic, more crowded, and more mysterious than the one we were promised. We are seeing red geysers, galaxies that are mysteriously dying and stopping star formation far earlier than they should. We are seeing supermassive black holes at the centers of these early galaxies that are millions of times the mass of our sun, growing at rates that violate the Eddington limit, the physical limit of how much matter a black hole can eat before its own radiation pushes the food away. It's as if the universe is breaking its own speed limits. Every time we think we've found a boundary, Webb shows us that the boundary doesn't exist. We are forced to consider that the vacuum of space itself might have properties we never suspected. Some physicists are looking into dark radiation, or quintessence, a form of dark energy that changes over time rather than staying constant. If dark energy is dynamic, it means the fate of the universe isn't a slow freeze, but could be something much more violent and unpredictable. We are currently in a period of creative destruction in science. The old towers of thought are being knocked down by the data streaming from Webb's golden mirrors. It is an uncomfortable time for many, but for those who seek the truth, it is the most exciting time to be alive since the days of Einstein. We are watching the birth of a new era of human understanding. We are realizing that our maps of the stars were just sketches made by people who had only seen a tiny fraction of the world. Now, the lights are being turned on, and the room is much bigger, much older, and much stranger than we ever imagined. The glitches we are seeing, the impossible galaxies, the Hubble tension, the early heavy elements, are the keys to the next level of our evolution. They are hints left by the universe, challenging us to think bigger, to abandon our biases, and to embrace a reality that is far more magnificent than any story we could have invented. As we stare into the deep field images, looking at light that left its source before the Earth even existed, we have to humble ourselves. We are a young species on a small planet, trying to decode the secrets of an infinite machine. The fact that we can even perceive these contradictions is a testament to human curiosity. But the James Webb Space Telescope has made one thing very clear. The universe is under no obligation to make sense to us. It follows its own rhythm, its own hidden clock, and its own mysterious laws. We thought we were at the end of the story of cosmology, but Webb has shown us that we are only on the first page of a much longer, much more complex book. And as we turn the page, we must be prepared to leave everything we thought we knew behind. One of the most radical ideas gaining traction in the wake of the Webb discoveries is the concept of tired light, or the variable speed of light. For nearly a century, we've assumed that the redshift we see in distant galaxies is caused exclusively by the expansion of space. But what if light itself loses energy over billions of years of travel? If light tires, it would shift toward the red end of the spectrum without the need for extreme expansion or ancient ages. While mainstream science has long rejected this, the impossible maturity of Webb's galaxies is forcing even the most conservative skeptics to look at these fringe theories again. If the light is simply changing its nature as it crosses the void, then the entire distance scale of the universe is a hallucination. We might be looking at a universe that is static, or one that is infinitely larger than the 14 billion light-year bubble we thought we were trapped in. Then there is the quantum foam hypothesis. Some physicists believe that at the very smallest scales, space-time is not smooth, but a bubbling, chaotic mess of quantum fluctuations. If the early universe was shaped by these fluctuations more than by gravity, it could explain the rapid clumping of matter that created those giant galaxies so quickly. It would mean that the macro world we see, the stars, the planets, and our own bodies, is just a thin crust sitting on top of a violent, unpredictable quantum ocean. The James Webb Space Telescope might be catching the last ripples of that quantum chaos before they smoothed out into the orderly universe we see today. We are effectively looking at the fingerprints of the Creator, whether that Creator is a set of mathematical laws, a quantum accident, or something even more profound. We also have to talk about the dark flow and its connection to other universes. Some theorists suggest that our entire universe is just one bubble in a vast, infinite multiverse. If another universe is sitting right next to ours, its gravity could be pulling on our galaxies, causing the weird motions we see, and perhaps even speeding up the formation of structures in certain regions. This would mean that the laws of physics aren't universal at all. They are just local bylaws for our specific bubble. In another bubble, gravity might be twice as strong, or light might move at half the speed. Webb isn't just showing us our history, it might be showing us the limits of our own existence. We are like fish in a pond, finally getting a glimpse of the ripples caused by things moving on the surface of the water outside our world. This brings us to the final, most haunting realization. Every time we build a better tool, the universe gets more complicated. When Galileo looked through his first telescope, he saw that the moon wasn't a perfect sphere. When Hubble looked through his, he saw that the Milky Way wasn't the only galaxy. And now, Webb is showing us that the Big Bang itself might not be the simple start we imagined. There's a pattern here. The more we see, the less we know. We are peeling an infinite onion, and every layer we remove reveals a reality that is stranger and more alien than the one before it. We are currently living through the great simplification of the old model and the great expansion of a new one. The tension, the broken physics, and the impossible galaxies are not errors to be solved. They are invitations to evolve. As we look toward the future, with even more powerful telescopes like the Nancy Grace Roman and the extremely large telescope currently under construction, we have to prepare for the possibility that the truth, with a capital T, might be beyond our biological capacity to understand. We are a three-dimensional species, trying to visualize an 11-dimensional reality. But that shouldn't stop us. The catastrophe that Webb has created is the greatest gift the scientific community could have received. It has shattered our complacency. It has reminded us that the universe is a wild, untamed place that doesn't care about our textbooks. It is a mystery that demands to be solved, a puzzle that spans billions of years and trillions of miles. We are the universe's way of looking at itself, and right now, the universe is looking back at us and laughing at how little we truly understand. Our journey is far from over. In fact, it's just beginning. The golden mirrors of the James Webb Space Telescope are still pointed toward the darkness, still collecting photons that have been traveling since the dawn of everything. With every new image, we take a step closer to the heart of reality. We might find that we are part of a cosmic cycle that has no beginning. We might find that we are living in a digital construct, or we might find something even more incredible, something for which we don't even have the words yet. But whatever the truth is, we will face it together, looking up at the stars and wondering what other secrets they are hiding in the deep, silent cold of space.